Hey guys, welcome back. Today we are going to talk about using the change of base formula in logarithms. So a way that we can solve log base 3 of 15. So we're going to take several steps here to find out what exactly that equals. First we're going to convert to exponent form. So that's going to be 3 to the x power equals 15. Okay, next we're going to set both sides in common log function. So that's going to be log 3 to the x power equals log 15. So both of these are common logs or log base 10. Okay, then we're going to expand, which means we're going to take this exponent and move it to the front here as a coefficient. So it's x log 3 equals log 15. And last, we are going to divide both sides to get log by itself. So we're going to divide both sides by log 3. So that's x equals log, I need to give myself more space there, x equals log 15 divided by log 3. And we can type that in just about any scientific or graphing calculator. Okay, so that's log 15, I'll close parentheses, divided by log 3, 2.46. So anytime we see a logarithm like, say, log base 8 of 17, we can change that to log 17 divided by log 8. Log of the argument divided by log of the base. That's the change of base formula. We went from a base 8 to division with 2 base 10s. So use the change of base formula to evaluate. So we've got log base 5 of 6. That is the same as log 6 divided by log 5. Log of the argument divided by log of the base. Log 6 divided by, I need to close those parentheses, then divide by log 5, and I get 1.11. Okay, so the value to this is that you can do this in just about any calculator as long as it's got a logarithm button. So then log 9 divided by log 7. Log 9, close parentheses, divided by log 7. 1.13. So we've got log base 8 of 11 minus log base 5 of 14. I can do change of base on both parts here. Log 11 divided by log 8 minus log 14 divided by log 5. Okay, so in my calculator, log 11, close parentheses, divided by log 8. And I'm going to close parentheses here, even though I didn't do that every time up here. It's just because I've got more to do after this. So close those parentheses, minus log 14 divided by log 5. Negative 0.49. Okay, so not every equation will ever use the change of base formula, but now we've got one more option when we're solving equations. So here, I don't think change of base is going to help. Log 15 over log x isn't going to really help us much. So this one, I'm going to change to exponent form. X to the 8th power equals 15. Now, if I want to solve this, I can raise both sides to the reciprocal power, the 1/8 power. Cancel that out. 15 raised to the 1/8 power. 1.40. Okay, so we're going to continue to solve some equations now. We've got about 6 more that we're going to do together, rounding to 2 decimal places. So once again, I'm going to put this into exponent form. X to the 2/3 power equals 11. And I can solve this by raising both sides to the reciprocal power, 3/2. So that's 11 raised to the 3/2 power. 36.48. Okay, this one is in log form, or is in exponent form, but I can change it to log form, and that's got a base of 3, an exponent of x, and an argument of 8, so that's log base 3 of 8 equals x. So here I can use the change of base formula that we just learned. Log 8, so that's log of the argument, divided by log of the base. Log 3 equals x. Log 8 divided by log 3. 1.89. So next we've got exponent form again. Let's change that to log form. We've got a base of 8, an argument of 90, and an exponent of 3x. Okay, so we'll do the change of base formula. Log 90, log of the argument over log of the base, log 8 equals 3x. To get x by itself, I need to divide both sides by 3. So I can do log 90 divided by, and I'm going to put in parentheses so I get all of this together, 3 log 8. And I've opened parentheses, I need to close both. 0.72. Here again, I'm in exponent form. We'll change it to log. I've got a base of 5, an argument of 49, and an exponent of x minus 2. So I'll do change of base, log of the argument over log of the base equals x minus 2. Then I need to add 2 to both sides. So I'm going to bring this over as a plus 2. So log 49 divided by log 5, close parentheses, so my division is complete, plus 2. 4.42. In number 9, I think it would be best to multiply both sides by 3. So we get x to the 5th power equals 18. And then I can raise both sides to the reciprocal, to the 1/5 power. 18 raised to the 1/5 power. 1.78. Okay, this one I've got x to the 0.6 power. That is the same as x to the 6/10 power, which I can simplify, or I can leave just as it is and raise both sides to the reciprocal, the 10/6 power. 20 raised to the 10�6th power. 147.36.